Bismillahirrahmanirrahim. Today we are going to solve Cambridge IGCSE Chemistry Paper 4 Theory for the session of May-June 2024, and we have the subject code 0620 and the variant of the paper is 42. We have 1 hour 15 minutes for this paper, and this paper is carrying 80 marks. So we're going to start our question paper from the question number 1. Question number 1 is similar to all those questions that comes in O-level and IGCSE exam. A list of gases is shown: ammonia, helium, hydrogen, carbon dioxide, carbon monoxide, chlorine, methane, nitrogen dioxide, propene, sulfur dioxide. Answer the following question about these gases. Each gas may be used once, more than once, or not at all. State one gas which is the main constituent of natural gas. We know that main constituent of the natural gas is methane, that is CH4. So we're going to write in our answer methane. Moving to second part, dash is responsible for both photochemical smoke and acid rain. We know that this gas is nitrogen dioxide. Again, this is given in the above options. So we're going to write nitrogen dioxide in our answer. Moving to third part is that it is unsaturated. So unsaturated are those gases that are alkenes that have double bond in organic compounds. So we know that propene is the alkene from the alkene group. So our answer would be propene for this part, because it is an unsaturated. Why it is unsaturated? Because it is carrying double bond. Dash has monoatomic particle. Next part is, we know that monoatomic should be noble gases, and noble gases from the above option is helium. So we're going to write in our answer space helium. Next part is reduces iron 3 oxide in blast furnace. So first we're going to write the reaction. You don't need to write, I'm just writing this to explain you how you approach to this answer. So I have already balanced the equation, so I'm putting it right. So we know that the gas that is reduces iron oxide into the blast furnace is we know that gas is carbon monoxide, and carbon monoxide from the above option is here. You can see from the list carbon monoxide. So we're going to write in the answer space as carbon monoxide. Next part is B part. Nitrogen dioxide, NO2 and carbon monoxide are removed from a car exhaust by a catalytic converter. Write the symbol equation for this reaction. So we know that nitrogen dioxide has the formula of NO2 and carbon monoxide has the formula of CO. When they are removed, it produces carbon dioxide and nitrogen gas. So this catalytic converter helps us to remove toxic gases from the atmosphere. So we're going to balance it like that. Here we're going to write 2, and now we have to balance carbon and oxygen. Oxygen over has 4. If I write here 4 as well, now you can see you have 8 oxygen, 4 2 to the 4, 8 oxygen. So this is well balanced chemical equation. Moving to question number 2. Question number 2 is that a list of 5 metals is shown: copper, iron, magnesium, potassium, silver. All metals form positive ions. Describe how atoms form positive ion. Atom is a neutral. They both carry equal number of electrons or protons. When they are positive ions, it means that they have loses the electron. It means by donating an electron they form positive ion. Next part is that state which of the 5 metals in the list has the greatest tendency to form positive ion. We note from the list that lithium, potassium, rubidium, cesium, francium, or you can tell it from the group 1, and group 1 in group 1 we can see that clearly potassium is the most easily formed positive ion. So we're gonna write that. Suggest one of the 5 metals in the list which is not likely to show catalytic properties. So you can write as magnesium and potassium, because they from the above list we know that copper, iron and silver, they both are transition metal, and magnesium and potassium are only metals, not transition metal. State 4 part, which of the 5 metals in the list of major component of stainless steel? We know that major component of stainless steel is iron, so we're gonna write iron in the answer space. Moving to its B part. B part is that a student add a sample of a metal to an aqueous metal salt in a beaker to see if a displacement reaction take place. Complete table 2.1 to show the color of the solution in the beaker at the start and at the end of the experiment. We know that we have magnesium and silver, and the aqueous solution is iron 2 sulfate and copper 2 sulfate. Color at the start of the iron sulfate is green, and color at the end should be colorless. So you need to memorize that. And silver is from copper sulfate, and color at the start would be blue, because silver cannot displace the copper, that's why it remains blue. But over here magnesium displaces the iron, that's why it becomes colorless change, because it does not give displacement reaction. Silver is a less reactive compared to copper, that's why its color does not change and it does not give chemical reaction. Okay, moving to its C part. C part is that most group 2 metals form a gas when placed into a cold water. An alkaline solution is also formed. Name the gas when strontium is added to cold water. We know that when metal, strontium is a metal, when metal is added to water, it produces hydrogen gas. Name the alkaline solution that form when the strontium is added to cold water. When strontium is added to cold water, it produces strontium hydroxide, like magnesium hydroxide. Okay. If you are confused about it, you need to give reaction like magnesium or calcium do. Okay. One group 2 metal reacts very slowly when placed into the cold water. When heated, the metal reacts with to form a white solid. Identify this metal and name the white solid form. We know that when magnesium is reacted with the cold water, it reacts slowly and magnesium oxide and hydrogen gas is produced. So magnesium is our metal and magnesium oxide is our white solid. So you're gonna apply that. Under the certain condition, iron will react with steam to form an oxide. Okay, with the formula Fe3O4. Fe3O4 reacts with dilute hydrochloric acid, that is HCl, to form a mixture of iron 2 and iron 3 salts and water. It means that we have the products iron 2, iron 3 and water. Deduce the symbol for the equation for the reaction between Fe3O4 plus dilute HCl, it means HCl. So first we're gonna FeCl2, because iron 2 chloride will produce, then iron 3 FeCl3 will produce, and also the water will produce H2O. Now this question is carrying 3 marks. We also need to balance the chemical equation. So we know that iron has 3, so there are 3 and over here is 1, so we're gonna put over here 2. Now we need to balance chlorine. Chlorine has 2 and over here chlorine has 2 3 is 6, then it means that it has 8, so we're gonna put 8 over here. Now we have hydrogen already balanced, it has 8 hydrogen. Over there it has also 8 hydrogen. Here oxygen is also balanced, oxygen has 4, and over here oxygen has also 4. So this is how you're gonna complete the balanced chemical equation. Moving to the question number 3. Question number 3 is that the symbol equation for the industrial preparation of ammonia is shown. N2 plus 3H2 would give you 2NH3, where delta H is, or enthalpy change is given, that is minus 90 kilojoule per mole. Name the industrial process. We know that this industrial process is known as Haber process. State the name of delta H. The name of delta H would be enthalpy change of the reaction. State the typical condition and name the catalyst used in the industrial production of ammonia. We know that the condition are it required 450 degrees Celsius and 20 atmospheric pressure, and catalyst used in this reaction would be iron. So moving to its D part, state two methods of increasing the rate of this reaction. You can increase this by increasing the temperature, or you can increase by increasing the pressure. So both these gonna increase the rate of this reaction. So this was an also a very easy part. Moving to its E part. E part is the topic belong to the equations, and E part is saying that the symbol equation for the reaction can be represented as shown in the figure. 3 bond nitrogen is carrying triple bond and 3 bonds of hydrogen, and NH3 and NH3 is produced. Show some bond energies. Okay, use the bond energies in the table 3.1 and delta H to calculate the bond energy of an nitrogen and hydrogen bond in kilojoule per mole. Okay, use the following step. Calculate the energy needed to break bonds in the reaction. So we first need to identify the energy that is needed to break down this reaction, and we know that nitrogen has 945 energy, and there are 3 hydrogen bonds, so it would be like that, 3 into 435. So 945 multiplied by plus 3 into 435 would give us the answer that is equal to 2250. So you're gonna write there 2250 as kilojoule. How we get calculated? By 945 and plus 345. I am also writing over here so you can clearly see that. Okay. Calculate the energy released when the bond is formed in the product. We know that product we have to find the energy, and we know that delta H is equal to bond breaking energy minus bond formation energy, and my delta H is given in the question, that is minus 90, you can see, and bond breaking energy is equal to 225. We have just calculated in previous part, and we need to find the bond forming energy, that is equal to minus x. So you're gonna apply mathematics here. X is equal to 2250 plus 90, you get the answer that is equal to 2340 kilojoules. You're gonna write it as 2340 kilojoule. Now next part is calculate the energy of NH bond. We know that there how many NH bond are there. We know that energy we just calculated in the previous part is equal to 2340. Now we need to find out how many NH bond are there. Okay, one bond is here, one is here, and one is here. So it means 3 bonds, and 4, 5th, and 6th. Total 6 NH bonds are present here. So you're gonna write as 6 NH bond. Now you need to divide 6 by 2340 to 6. After dividing it, you get the answer that is equal to 390 kilojoule per mole. So this is our final answer for the NH bond energy. Hopefully you have the understanding of this question. This question was interesting and very easy question, but required some sort of calculation. Some students do tend to shy away from these calculations. Moving to its F part. An incomplete symbol equation for the preparation of ammonia in the laboratory is shown. Calcium oxide CaO plus ammonium chloride 2NH4Cl gives you CaCl2 plus 2NH3. And over here we know that what is missing, that is equal to water. So you're gonna write that H2O to complete this reaction. Complete the symbol equation. So we have just completed. Name NH4Cl. We know that its name is ammonium chloride. So you're gonna write as ammonium chloride. Calculate the volume of ammonia NH3 measured at room temperature and pressure, which form when 1.12 gram of CaO is heated with excess NH3. So I'm gonna write this equation which is written over here. So you get the idea. CaO plus 2NH4Cl would give us CaCl2 plus 2NH3 plus water. Okay, we have been provided with the information that masses of calcium oxide is 1.12 gram, and we need to find the volume of ammonia. It means we need to find the volume of ammonia. Over here you can calculate the moles easily by dividing it. A smaller mass, it would be 40 plus 16, 1.12 over 56. You get the answer, that is equal to 0.02 moles. And we know that over here you need to compare it 1 mole, and it over here are 2 mole. If it's 0.02, so over here its moles would be 0.02 multiplied by 2, which you would get, that is equal to 0.04. Now you need to multiply to a smaller volume, and smaller volume would be 0.04 multiplied by 24. After multiplying it, you get the answer, that is equal to 0.96 decimeter cube. Okay, now you can need to understand that we need to give our answer in centimeter cube. So we're gonna multiply 0.96 by 1000. After multiplying it by 1000, you get the answer, that is equal to 960 centimeter cube. So this was an easy stoichiometry question or moles question. Hopefully you have the understanding of this question and you get the solution of this question clearly. Now we will move to the question number 4. A carboxylic acid reacts with an alcohol to produce an ester and water. Okay, under certain condition this reaction can be reversed, so an ester with water to produce a carboxylic acid X and alcohol Y. Okay, this reaction reaches an equilibrium. CH3 CH2 COO CH3 plus H2 would give you X plus Y. The forward reaction is endothermic. Reduce the empirical formula. First you need to identify its molecular formula. Over here you can see that we have 4 carbon atoms, 8 hydrogen atoms and 2 oxygen atoms. So its formula will be 482. So we know that they have the common multiple of 2. So after dividing it 2, we get the empirical formula C2H4NO. Name that ester. Ester would be methyl propanate. It's like it has CH3 and 3 carbon atoms are there, so that's why it is propanate, methyl propanate. Name the carboxylic acid X and draw its displayed formula. So from it we know that it would form propanoic acid, and the formula for the propanoic acid should be like that: 3 atoms of carbon and OOH, so it would complete acid, and of remaining carbon atoms should be filled with hydrogen atom, so that you complete the reaction. Hopefully you have the idea of this structure. Name alcohol Y and give its structure formula. Alcohol Y would be methanol and its structure formula will be CH3OH. So this was very easy question. Moving to its E part. E part is that complete table 4.1 to show the effect, if any, for which E change of condition effect on the concentration of carboxylic acid at the equilibrium. So we are talking about this. When temperature is decreased, we know that rate of reaction also decrease. So we're gonna write decrease. Concentration of methyl propanate is decreased. When its concentration is decreased, we know that carboxylic acid would form less, so it would also be decreasing. More alcohol Y is added, so it also decrease the reaction. A catalyst is added. Catalysts have no effect on this reaction. So that was easy 4-mark question. Moving to its that part, F part is that at the beginning of this reaction between the ester and the water, no carboxylic acid is present in this reaction mixture. Suggests how the pH of this reaction mixture changes from the start of the reaction until equilibrium is reached. Assume alcohols and esters are neutral. We note that if they are neutral, its pH from the start would be 7, and at equilibrium it should be acidic, so you can write 4 or even you can write 5. Both these answers will be considered correct. Second part, identify the ion that causes the change in the pH. We know that the concentration of hydrogen ion changes, so we're gonna write that H positive. Name an indicator which can be used to follow the change in the pH. So we can use universal indicator to follow the change in pH. So this is how we have done question number 4. Moving to question number 5. Question number 5 is that sulfur is a group 6 element. A sample of sulfur contains two isotopes S32 and S34. Complete table 5.1 to show the number of protons and neutrons in one atom of each isotope of sulfur. We know that protons do not change, so from the periodic table we can see that it has 16, and number of neutrons is gonna subtract from 32. From 16 you get the neutron 16, and from 34 minus 16 you get the answer, that is equal to 18. State why these isotopes have identical chemical property. Because identical chemical property depends only upon the number of electrons in their last shell. So you're gonna write the same number of electrons in their outermost shell is the reason they have the same chemical property. State the mass of 6.02 into 10 to the power 23 atoms. It means it is equal to Avogadro's number. Include unit S34 in your answer. So we know that it is S34, so it should be equal to 1 mole, and 1 mole of it should be equal to 34 gram. State the name of amount substance which contains 6.02 into 10 to the power 23 atoms, so it should contain only 1 mole. Table 5.2 show the relative abundance of these isotopes of sulfur in the sample. We have been given with the atom and the relative abundance 95% of S32 and 5% of S34. Calculate the relative atomic mass of sulfur in this sample to 1 decimal place. So you're gonna multiply it 32 to 0.95 and 34 to 0.05. How you get the 0.05? By dividing it by 100 and also dividing by 800, and then adding them, you get the relative atomic mass, that is equal to 32.1. I am again repeating this. You get the value of 0.95 by dividing 95 to 100, and you get the value of 0.05 by dividing 5 to 100, and after multiplying it to their molar mass, you get the answer, that is equal to 32.1. So this is the relative atomic mass of sulfur. Moving to its B part. B part is that sulfur reacts with magnesium to form magnesium sulfide MgS, an ionic compound. Complete the dot and cross diagram in the figure 5.1 of the ions in the magnesium sulfide. Give the charges on the ions. So we know that magnesium has the formula, the magnesium has the structure that is equal to 282. So you're gonna draw 2 and 8, and we know that it loses 2 electrons, so 2 electrons would be completed here. So you're gonna write here. So we know that 2, 8, and in the last shell of sulfur should have 6 electrons. So it is completed by S. So it has accepted 2 electrons, so that's why it has -2. So it donates 2 electrons, that's why it has +2. So this is how you have done that. State why MgS has a high melting point. Because ionic bonds are strong, so that's why they have the high melting point. State why molten magnesium sulfide conducts. Because ions are free to move. We know that ionic compounds do not conduct electricity in the form of solid, but they do conduct electricity when they are in the molten or aqueous form, aqueous solution. Moving to part C. Part C is that an acid containing sulfur reacts with sodium hydroxide NaOH to form a salt and water. The salt has the formula of Na2SO3, not Na2SO4. So you gonna deduce the formula of the acid, that should be equal to H2SO3. Do not do the mistake by writing H2SO4 because it clearly shows it is SO3, so you're gonna write H2SO3. Deduce the formula of Na2SO3. You know that Na should have Na positive 1 and it should have SO3 minus 2. So this should be there, and so you're gonna write SO3 minus 2. Na2SO3 is oxidized by acidified aqueous potassium permanganate. Potassium magnate. State what 7 refers in the name of potassium magnate. 7 refers the oxidation number. This was an easy question. State the color change when this reaction happens. It changes from purple to colorless. This is a very famous reaction and this is a very famous indicator. Okay, moving to last question of our paper, that is question number 6, that belongs to the topic of organic chemistry. Question number 6 is that glucose is involved in 2 processes. Glucose C6H12 and O6 is made in plants from carbon dioxide and water. Name this process. We know that this process is photosynthesis. We write the symbol equation for this process. We know that carbon dioxide and water reacts, they form glucose and oxygen gas is produced. So we're gonna write that CO2 plus H2O would give us C6H12O6 and O2. And after balancing it, you're gonna write 6 CO2 plus 6 H2O gives C6H12O6 plus 6 O2. State 2 essential condition needed for this process to happen. We know that 2 essential conditions are energy from the light and chlorophyll. Part B. Glucose is converted to ethanol. Name this process. This process is known as fermentation. Name the other product formed when glucose is converted to ethanol. When glucose is converted to ethanol, the other product is carbon dioxide, that is CO2. Moving to part C. Part C is that ethanol is made by reacting ethene with steam in an industrial preparation. State the condition and type of catalyst used in the industrial production of ethanol. You need to memorize that temperature and units are 300 degrees Celsius, pressure and its unit 60, pressure and its unit are atm, that means atmospheric pressure. Type of catalyst that is used, that is acid. Explain why this reaction is an addition reaction. Because only one product is formed, so that's why it is an addition reaction. Moving to last part of last question. Complete the dot and cross diagram in the figure 6.1 of a molecule of ethanol. We know that ethanol have a formula of C2H5OH. C2H5 and OH. So you need to complete dot and cross. First you need to complete carbons. Second shell should have 8 electrons. By putting it dot cross, dot cross, dot cross, dot cross, this carbon has 8. Now this carbon should also have 8. Dot cross, dot cross, dot cross, dot cross, so this is 8 also. Now oxygen should have 8, so in their last shell. So 1 2 3 4, these are the 2 lone pair and 2 bond pair, dot cross, dot cross. So oxygen 8 has completed. Now you need to check hydrogen just in case you miss anything, so you must check it because this question is carrying 3 marks and each mark is important to get an A at the end of the day, which is matter. Okay, which matters only. Okay, dot cross, it means hydrogen should have hydrogen's first shell should have 2 electrons. Dot cross, dot cross, dot cross, dot cross, dot cross. So you can clearly see that all carbon and all oxygen and all hydrogen atom have completed their octet and duplet shells. So hopefully you get the understanding of this paper. If you do have any queries related to this paper, you can ask in the comment section. Your queries will be replied ASAP. So and if you find this video helpful and useful, do not forget to share with your friend and also subscribe my channel and do support this channel for further videos like this. Thank you so much for watching this video. Allah Hafiz.